So basic definition, guys. You always read a graph left to right. That's what all this means. All this stuff right here means. If the graph is increasing, if it's left to right, if it's going up, you're increasing. If the graph left to right is going down, you're decreasing. Does that make sense? Okay. So what's an example of an increasing graph? Y equals x. Left to right, it's increasing. Or y equals x cubed. What's an example of a decreasing graph? Y equals negative x cubed. Cool? All right. Extrema means extreme. And all that basically means is that we're looking for extreme values. So we're either looking for maximums or minimums. Yay or nay? Okay. The extreme value theorem. All the extreme value theorem says is if you have a closed interval, it doesn't matter how the graph looks, as long as it's a closed interval and it's continuous, closed interval and continuous. If you have a closed interval and continuous, you have a max and you have a min. That's all it means. Cool or not cool? All right, so let's practice. So let's draw out some scenarios. Obviously, to make things easy, guys, in the beginning, I'm going to make all the graph y equals x squared. But this one, it's going to be from the domain 0 to 2. So y equals x squared looks like this. 0 to 2. Because it's a closed interval, my min happens down here, min, and my max happens up here. And that's all it says. That if you have a closed interval, you have a min and a max. I'm looking now, I'm going to do this graph. I'm going to go y equals x squared again. And I'm going to go from 0 to 2. But notice the 0 has an open circle. Do we notice that, guys? So this looks like this. Do I have a min? No. No minimum. No min. Do I have a max? Yes, it has a max. Cool or not cool? Thank you, miss. All right. Y equals x squared. And notice that this time my domain is 0 to 2. And notice that I do not have a bracket on any of them. Open circle, open circle. Do I have a min? Do I have a max? Correct. No min, no max. Now, let me ask you this question. Just because I have an open interval, does that mean that every function is not going to have a min or a max? No, not necessarily. What if I have something like this? I'm just going to make something up, guys. What if I have something like this? Open circle. Oh, no. Open circle, and then open circle. What does this have? Just a max. It has a max way over here at the very top. Does that make sense? But this one doesn't have a min. How do we feel? Ask. What's up? Oh, it is a value because it's continuous. It's continuous, but it's just not. It's just not the at the end points. You're not continuous. Yeah, like we have to be continuous on a closed. Well, okay. For the extreme value theorem, you have to be continuous. You have to be closed interval always. Now, for you to have a max or a min, you can have an open interval and have a max or a min, as long as you're within your open interval, you're continuous. I think I said that correct. Cool? Okay. All right. So now let's look at this, guys. I think we've covered all the scenarios. Yeah, close, close, close. Okay. Can you think of a situation where you have a maximum and a minimum for every point? You can't think of one? Look, closed interval, closed interval. A horizontal line is both a max and a min at every point. Both max and min at every point. How do we feel? Okay. You're going to see a whole bunch of words all the time, local and absolute. Local is not the only words that I use. Let's see what this says. It says, let's chat about the difference between a local min-max and an absolute min-max. Observe the behavior of f prime. Okay. The other word that they use besides local is relative. Like your relative, like your tío, your tía. That's local. It's the same as local. What's another word for absolute? You use it in economics all the time. GL, no, not GDP. That's gross domestic product. GL, global. Global? You've never seen global? Okay. Yeah, gross domestic product, of course. Okay. Absolute is the same as global. Absolute means there is no other point bigger than that. Does that make sense? So if I tell you this is the absolute max, that means this is the max of all maxes. There is no other point bigger than that. If I tell you this is an absolute min, that means this is the min of all mins. There is no other point below that. Does that make sense? What's up?
Infinity or negative infinity?
No, it has to. You have to. Infinity does not converge to a number. It just keeps going up, 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 or down, down, down. So those can never be.
Okay, so then in terms of like a global max,
the biggest max.
Would we just say that it's not?
If it's,
for example, like a graph have like an arrow.
Like x squared. X squared goes up forever. That has the absolute min, but does not have any max.
Okay, but if it was like this one, the one that we did here, would you just say that doesn't have a max or a min?
Correct. Something that's always increasing without bound? Yes. Okay. What was I going to say about this? I already forgot. Oh. All critical points. Did I already talk about critical points? No, okay. Then I'm going to say all max mins, all of them, are all local. Because locally, think about what local means. In the vicinity, all those points, if it's a max, that is also a local max. It could be a possible global max if it's the biggest from all of them, but all locals, all maxes are locals, but not all locals are globals. Does that make sense? All globals are locals. Yeah, it's a tongue twister.
Oh, yeah. So it's like the square.
Yeah. Like, look, let's talk. Let's talk real quick. Right now, I just want to know, is it a max or a min? So look at X1. Is X1 a max or a min? It's a max. I'm going to put max. I'm going to put local for now. Look at X2. Max or a min? It's a min. And so look, notice that they're all in the vicinity. That's the smallest there is, right? What about X3? Is it anything? No, it's nothing. It's not a max or a min. What about X4? For sure, it's a local max. What about X5? Local min, it's a minimum. X6, is X6 anything? No. And then there's something about endpoints. We'll talk about them later on. Some text, okay, you know what? So we're already talking about it, so let's talk about it. Our textbook, the Demano Waits textbook, calls point A a local min. Some textbook will not call an endpoint a min. Ours does. I think it's okay. In the vicinity, is A a min? Yes. So I think it applies. At point B, we would call that a local max. Now, when you get to your university, depending on which one you go to, some textbooks will not say you have a max or a min at endpoints because of the definition. Because there is no pixel to the right of that. Are we okay? Okay. Now let's look at the whole picture. Do I have a global min?
Yeah.
Which one? X2 is a global min. You could also use the word absolute min. Both of those words are interchangeable. In the vicinity of the whole from A to B, there is no lower point than X2. From A to B, is there a point that's higher than any other point? It looks like it's X4. You can call that an absolute max, or you can call it a global max. So, absolute. If it looks like it's the same height, but I think this one looks like it's a little bit higher. Absolute max. You could also say global max. No. I'm just writing both so you know, depending on the language that they use. AP uses both of them, and textbooks go back and forth depending on who your author is. Hey, no yawning, that's a demerit. Look, And I know some of you have been awake all night long. You haven't even slept at all. What's up? Yes. Okay. The question is, can there be two global maxes? There can, but they better be the same value. You know what I mean? So let's say the B1 was way up here, and it looks like it's the same height as this one, then you would call both of them global max, because it's the same. Does that make sense? Global just means from all the points, this is the highest it goes. And if there's another point that is that high, then you call that one a global.
In relation to like a sinusoid, would every single max and min be a global max?
If it's a sinusoid, yes. But they're not going to ask that because they want to make sure that you really know.
But I'm just saying,
Yeah,
like, there
yes.
is no limit to the amount of global maxes or
Correct.
mins you have if they're the same value.
Yes. Are we okay so far, guys? Okay. So here we go. We're finally getting into, okay. I was supposed to observe something that we didn't observe. Tell me something that happened at the local max at x1. Between A and x1, tell me something about f prime. So f prime was what? Positive or negative? Positive. Here's how you say f prime positive. Notice that as soon as you pass that x1, f prime turned to a negative. Do you guys see that? Okay, now look at x2. To the left of x2, f prime is negative. And then as soon as I pass x2, f prime is positive. So was there a sign change for max and a sign change for a min for f prime? So start getting that in your head. If f prime changes from positive to negative, f has a max.
So that's why people kind of argue. That's why people are like 50-50 regarding endpoints as being max and min.
Yeah, because there's no sign change on it. It's just at x3, notice nothing happens. F prime is positive to the left, f prime is positive to the right. I'll write it. F prime positive, f prime positive. See? At x4, look at x4, how it went from positive and all of a sudden f prime is negative. So positive to negative, I have a max. At x5, I was negative, f prime was negative, and then f prime turned to a positive. Do we notice that? At x6, f prime is still positive. There's no sign change. And notice that at A and at B, those are endpoints, so we'll talk about those when we get there. Some textbooks call them, do not even put them in a discussion for max mins. Some do. I spoke to a math professor who has a doctorate in math. Well, obviously all of them do. And she told me that a lot of professors are on the fence on them, but that she, Dr. George, agrees that those are local max mins and they can be global if it's the highest point. Because by definition, it's, so, okay. It just depends who you ask. Okay, go to the next page. Here is what you're going to call a critical point. If the derivative is 0 or the derivative does not exist, you're going to call those critical points because something is happening there. Are we okay? Okay. And then notice, don't worry, it says increasing or decreasing. If f prime is positive on this interval, then f increases. That's all it's saying. If f prime is positive, remember that f prime stands for slope. If the slope is positive, then the function f has to increase. Does that make sense, guys? Oh, no? Okay, sorry. Okay, all right, if f prime is negative, that's how you say negative. So that's how you say positive. Let me write this down for good notes. POS. Oh, I better write everything because I'm going to think something else. That says positive, and then this means negative. Don't cry.
I just rolled. I scratched my eye. Oh, no.
Silence.
I would like.
All right. Are we okay so far? All right, so look what it says. Look what it wants us to do. First derivative test for local extrema at a critical point C. F prime changes from positive to negative at C. So I'm going to show you two scenarios. So I'm going to draw a grid. It doesn't have to be perfect. I'm going to say C is right here in the middle. And I'm going to show F. This is F, the graph of F. And look. At that moment, f prime is 0, just at that moment. To the left of that, f prime is positive. To the right of that, f prime is negative. Cool? Here's another moment. Chav, can you show me one where f prime of c does not exist? Sure. Let's see. F prime equals DNE.
Oh, it's what's it called?
It's a corner.
Bro,
You can also say cusp.
what do you think of the word? It is a word, no? Non-differentiable. No, it was like something else, right?
How do we feel? All right. Here we go. Let's go to the next one. Oh. F prime changes from negative to positive. I know, guys. I know you guys are tired. You guys have been up since midnight. F prime changes from negative to positive. So here we go.
It's the same thing, but it's like going up.
Yeah, I like that. At that moment, f prime is 0. F prime is negative. F prime is positive. This is f. Ask, what? Talking smack? What's on the board? Oh, the restaurant? No, I didn't get a chance. I'm not fake, miss. Miss Gonzalez, tell them something. When she listens to this, she's going to beat you guys up. Nah, she'll probably. They're talking smack, miss.
But even if f prime at like point C is like, even if f prime is equal to even if f prime does not exist at point C, it's still a critical point, right? So
a critical point is defined by equals 0 or does not exist.
But that could be a local min.
It is a local min. All max and mins happen at critical points. Unless you count an endpoint as non-critical. Let's see, f prime does not change signs at C. So it could happen like this. And the graph is f. It could happen like this. Let's do a min. See, you don't change signs. This one's going down.
Oh, sorry.
It's not a max or a min. It just wanted something that did not change signs. I know on the others I've kept them the same pattern. What up? Ask. What's up? No, ask, miss. It's all good.
No, this is like the same thing.
Yeah. Nothing's happening pretty much. At a left endpoint, A. So we're gonna say if at A, so here's a left endpoint. I'm gonna call that A. If at A I immediately start decreasing, we're gonna call this a max. Max at x equals A. Does that make sense? Let's see. If f prime is greater than 0 for x is greater than a. Okay, so if that happens, I'm looking at scenario number 2. And let's see, f for x greater than a. So that means a is still at the left side. So now I'm increasing. So we're going to call that a min at x equals a. Don't worry, we're not teaching to the test, but the AP exam will be nice. I think we will not be nice, but the AP exam will. No, we are nice to all people. I never. Well, we're gonna give you the hard questions. Yeah, but that's okay. So if the derivative is negative and you end at an endpoint, that means this is happening. That's a min. If the derivative is positive and you end at an endpoint, then you have a max.
So this is when you argue that endpoints are minimum to maximum.
Yeah, some textbooks will not. If you Google this, some textbooks will say that you cannot have max and mins at endpoints, and some textbooks will have them. So don't come to me and say Khan Academy says that you can't have max and mins. I'm gonna be looking at you and like, look at what Temena says. It depends on what textbooks you have, guys. So if you go to if you have a famous tutor that you like to go to, my favorite is, what's her name? She's been my favorite for like a decade now. No, not Virg Cornelius. She's an actual teacher. Oh, King, Miss King. If you go to Miss King says you can have max and mins at endpoints. It just depends who you go to, guys.
I like that girl that doesn't want to fall. Yeah.
The one that drives, that rides backwards? Yeah, she must be pretty brilliant for her to do that.
She was at
Okay.
MIT. Yeah.
I think she still goes to MIT. All right, you guys ready? So look what this says. It says find the critical numbers of f. All right, guys, focus. Find the critical numbers of f and classify the extreme values given by. So here's a function. For something like this, I would not be taking derivatives. I would just literally graph this. Why? Because look, they're all linear lines. So I can see that at 1 and at 5, because the slopes are different. Child, what are you talking about? I have a slope of -3, then I have a slope of 1, then I have a slope of -1. So that means I have corners at 1 and at 5. Do you guys see what I'm talking about? No? Okay. Just in case. Do you at least see this? A slope of -3, a slope of 1, and a slope of -1. So that means this is what's happening. A slope of -3, a slope of 1, a slope of -1. See? Corner. At those corners, those are critical points. Does that make sense? So something like this, I would just go ahead and graph it. Chop, how? Like this, guys. Start with a grid. And then I'm going to go at 0, you're at 0. So I'm going to choose red. At 0, you're at 0. Solid. How do you do that? -3 times 0. At 1, you're at -3. I'm going to say 1's right here. So I'm going to say -3 is, not to scale, I'm going to say right here. Point. Oh, no, open circle. There's my linear line. Does everyone see how I got that? Yes. It has doesn't have an equal sign there. At 1, and I'm going to color code it with blue. At 1, 1 minus 4 is -3, so I'm back at that same location. It has an equal sign, so I close that circle up. At 5, I'm going to say 5 is like way over here. 5 minus 4 is 1, so I'm going to say 1 is like, bam. And close circle. Connect them. Do you see what we did there, guys? Okay. At 9, let's see. 6 minus 9. Oh, sorry, I'm at 5. At 5. 6 minus 5. 1. So I'm there again. Open circle, but the blue one covers it up, so no big deal. So it's closed. And I'm going to say 9 is like, right here. At 9. 6 minus 9. So I'm going to back here at -3. Bam. Oh, look, that scenario just happened that you were asking earlier, Ms. Pericello. I have two minimums, but those minimums are also, though they're all local, all of them are local, but are also global because that's the smallest they ever go. Does that make sense? I only have one maximum, but, well, actually I have two maximum if you consider that endpoint. But at 5, that has to be an absolute max. Does that make sense? So I look for that. Let's see. Critical number at 1, yes. I'm looking at letter choice A. Local and absolute min at 1, -3. Local min at 0, 0. It looks like letter A, check mark. Wait, is 0, 0 a min? No, it's a max. Nope, that's out. Oh, UH, by the way, does endpoints max min. Does everyone see why letter A is out? Yeah. Because 0, 0 is not a min. 0, 0 is a max. B, no critical numbers. Nope, letter B is dumb. C, critical numbers at 1 and 5? Yes. Local and absolute min F1 -3. Local max at F of 5, 1. Absolute min F of 9 equals -3. I'm going to say technically it's correct, but I also want to see that F of 9 is also an absolute. Oh, it does say absolute. Okay, I think we found it. I think it looks letter C. Letter D, let's see what letter D says. Critical number at x equals 1, 5. Local and absolute min F of 1 equals -3. That's true. Local and absolute max F of 5 equals 1. Absolute min F of 9 equals -3. How does C and D differ?
D says that it's absolute and local for the max. For the wait, yeah, it says the max. For the max, it says it's local and absolute. It says local. It's D.
Oh, okay.
It says local and absolute max.
Local and absolute max F of 5 equals 1. Absolute min. It says the same thing. Oh, okay, got you. Local max at F of 5, but this one says local and absolute max F of 5. Letter D. Well, that was a close one. How do we feel? Yeah, that one was a little hard. Okay, look at this one. For what value of x does a function have relative maximum? You don't have a calculator? Let's assume we don't. So I need to find my first derivative, and I need to see how often my first derivative changes signs. I have a relative max from positive to negative. Does that make sense to you guys? I'll say it again. Let's do a game plan. For what value of x does a function have a relative max? Remember that you have a relative max when f prime changes from positive to negative. Sorry, that's really bad handwriting. Cool or not cool? Here we go. F prime of x. I'm doing product rule. First, times root of the second. 2x minus 3, close, times 1. That's good. Plus second, x minus 3 squared times root of the first. 1. Oh, that's nasty. That's not, I mean, yeah, it is, but all right, let's see. I'm going to factor out an x minus 3. And if I factor out an x minus 3, I have 2x minus 4 plus x minus 3. Let's see, is that anything? X minus 3, 2x plus x, 3x, 4, 5, 6, 7, minus 7. Okay, equal that to 0. This is how you get your critical numbers, correct? All right, I have a critical value at 3 and a critical value at 7 over 3. These are candidates. Well, I already see that 3 cannot be it, so just by rule of thumb, it has to be 7/3. Don't worry, we're going to explain it. That's not even the best explanation. These are... Oh, yeah. I factor out an x minus 3. All right. These are candidates for max and min. So do a railroad track. I'm going to do the railroad track up here. F prime. Let's see, 3. I'm going to say 3 is right here. And 7 over 3. You got to have a little bit, yeah, you got to have a little sense of number, guys. Not even extreme. You just got to know, like, 3 goes into 7 twice and you have 1 left over. So it's like 2 and 1/3. Hey, Uncle Seth. Are we okay with that, guys? Okay. So then here's what you do. Relax. It's simple. Plug in a number to the left of 7/3, like 0. Child, where do I plug it in? Plug it into whatever you think is simplest. I think it's simplest right here. So if I plug it in there, 0 minus 3, that's a negative. 3 times 0, 0 minus 7, that's a negative. Negative times a negative is a positive. Put a plus. Now I'm going to plug in a number bigger than 7/3, like 2.5. 2.5 minus 3, negative. Excuse me. 3 times 2.5 is going to be a bigger number than 7. So what is negative times a positive? Negative, there it is. So there it is at 7/3. If I plug it, but don't finish. Plug in a number bigger than 3, like 5. 5 minus 3 is positive. 3 times 5 is 15. 15 minus 7 is positive. Positive times a positive? Positive. It wants a relative max. That happens when your f prime changes from what to what? Positive to negative, and that happens at 7/3. Do you see how we did it, guys? All right. Example 3. Find the interval in which the derivative is increasing. In which, did I say derivative? Darn it. I'm not tired. I really am not. I don't know why I'm saying wrong things. Find the intervals in which the function is increasing. I think it's because someone yawned and they made me want to yawn. Look what you did. Look what you made me do. I saw that, Alvarez. The next person that yawns, I'm going to call Miss McLaren. I'm going to call her on my phone. Oh, try me. All right. Sorry, guys. You guys are funny. Give me the... All right, guys. Sorry for disrupting you guys. Give me the derivative of 7x to the 4th. Give me the derivative of 4x cubed. All right. So now the next is just all algebra. What can I factor out of the 28x to the 3rd plus 12x squared?
4x squared.
So I'm going to have 1 on the inside.
7x.
Yeah, go ahead.
Plus 3.
And I want this. Okay, I'm going to equal it to 0 first so we can do a row tracks. So I have a double root at 0. And I have, let's see, 7x plus 3 equals 0. So 7x equals negative 3. So x equals negative 3/7. Here's my row tracks. Here's a 0. Here's a negative 3/7. I don't see any mistakes at the moment. Nope, no mistakes. I'm going to choose a number to the left of negative 3/7, like negative 1 or negative 2. It doesn't matter. The 4x squared will always be positive, so you don't even have to worry about that. 7 times negative 1 is negative 7, plus 3 is another negative number. Negative. Does everyone see how we got that? Okay, then I'm going to choose a number like between negative 3/7 and 0, like negative 1/7. So let's see. Positive, 7 times negative 1/7, it's going to be a negative 1. Negative 1 plus 3 is positive, so that's a plus. And then I choose a number to the right of 0, like 1. Positive and positive, so I get a plus. All right. So here's what...
Wait, what did you plug in? Between negative 3/7.
I plugged in a 1. Oh, a negative 1/7.
Oh, I thought you plugged in negative 1. I was like, how did that?
So here's where f prime is positive. F prime is positive on negative 3/7, comma, all the way to 0, and 0 all the way to infinity.
Yeah, question.
So, yeah, go ahead.
Why is the negative 3/7 not in brackets? Because there's no like, because they're
You know, you actually can put it in brackets because you increase or decrease on an interval. So we actually can put it, but I'm just talking about where, see how I wrote f prime greater than 0?
Oh, there's no.
So right at negative 3/7, it is 0.
Okay.
You know what I mean?
Yes.
Okay, so where am I increasing, guys? Can I just leave it like that? Is there a better answer? There's actually a really good answer, like a superb answer.
Negative 3/7 to infinity.
Yeah. What did I put on the negative 3/7? A bracket?
Well, in this expression you have right now, no. Because
In the expression that I have right now, where I said f prime is greater than 0, no. But notice what I have here by the definition. So I can write it like this. And don't worry, there's so many debates on this, but in the end, this is the right way. End of story. But there's a lot of reasons why we learn this. This is actually applicable to like real data analysis. You know, when is the rocket fuel at its maximum? All right. No, there's so many scenarios, like create like real life scenarios. All right, here's how you would write it, guys. F is increasing. You increase or decrease on an interval, yes or no? F is increasing on the interval, bracket, -3/7, comma, infinity, parenthesis, close. Does anyone have issues about the bracket and the parenthesis and why we didn't break it up into two?
How do we know that we have a bracket?
Because you increase or decrease on an interval and on a closed interval. But it's okay. We would not count it wrong if you were to put parentheses.
Would it be?
No.
So is it because the first one that we did where we like separated into two, is it because the first one we were looking at like the slope increasing, and then on the second one we were looking at it like the points are increasing?
Yeah, we're looking at the points. Look, side note, because I really want you to get this. Ready, Tavar? We all know how y equals x squared looks like, right? It's a parabola that looks like this. Correct? Right at x equals 0, you have a horizontal tangent, so you're not increasing or decreasing at 0. But if I were to tell you, where are you decreasing? You would tell me, well, okay, there's two different things. If I tell you, where is f prime negative? You're going to tell me f prime is negative from negative infinity all the way to 0, and you wouldn't put a bracket on that because you're just looking at where f prime is negative. Right at 0, it's not negative. Right at 0, it's 0, right? So, but if I tell you where am I decreasing, what this says, I'm looking at this definition right over here, right here. All you care about is you're reading a graph left to right. And as long as the pixel to, like, when I talk about pixel, I'm talking about like literally at a point. As long as the pixel to the right is larger in magnitude or the y value than the pixel to the left, then that's considered increasing. So like a graph like y equals x squared, you're like, Chav, you're confusing me even more. So like a graph like y equals x squared, pretend you had a calculator that can zoom in into x squared like extreme. So you keep zooming in, keep zooming in, keep zooming in, keep zooming in, zoom, 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 and you just zoom, zoom, zoom in on that sucker. You can decrease from negative infinity all the way to 0 with a bracket on it. Because right at 0, I know you're not increasing or decreasing, but at the pixel at 0, the one to the left is a little larger.
Because 0 is the initiating point.
0 is where I stop. Boom.
Yes.
Well, for decreasing.
Yeah.
Yeah.
But 0 is always going to be the point where you initiate an increase or you decrease.
Yeah.
Is the beginning of that increasing and decreasing.
Yes.
Okay.
Okay, but I don't want you to. Okay, if you don't understand this, it's okay. You'll still get it right. But hopefully that made sense. So you're increasing from 0 to infinity for the x squared function. Ooh, that was a hard one. Okay. A little bit. I'm just out of shape. It's because I started eating and I didn't exercise last week. But I'm going to start exercising again. All right, here we go. I ate a lot. All right, find intervals on which this function is increasing. So I am finding where this derivative is positive. Find where f prime is positive. So here we go. Ready? F prime equals, I'm doing quotient rule, bottom, x squared plus 49 times derivative of the top, plus or minus? Minus top times derivative of the bottom all over bottom squared. Are we okay so far with that? I'm going to equal this to 0. We're finding critical numbers. Cool? So here we go. Do I want to distribute that 6? No. I mean, I kind of do, but I kind of don't because I already see a 6 right here. So can I just factor out a 6? Yeah, so I'm going to do that. Here's my 6 factored out, and I'm going to have, let's see, x squared plus 49, let's see, minus 2x squared, close, equals 0. So let's see, what, all this is over x squared plus 49, but I don't care about the, actually, no, I don't. I don't care about the bottom because it'll always be defined. Let's see, 6 parentheses, negative x squared plus 49 over x squared plus 49. I don't see any mistakes. So then I see x equals plus minus 7. Are we still okay? So here we go. I'm going to draw a railroad track. I'm going to put f prime, negative 7, and 7. I'm going to choose a number to the left of negative 7, like what? Yeah, negative 10, negative 20, whatever number you want. Negative 10. Negative 10, don't even look at the denominator. It's always squared, so it's always going to be positive. Negative 10 squared is 100, but I have a negative in the front. So it's negative 100. Negative 100 plus 49. Is that positive or negative?
Oh, wait, negative 100 plus 49.
Negative.
Sorry.
Wait, no, sorry. How to get x equal to plus 9?
Because.
What numbers, yeah, I skipped a step. I just said what number will give me a 0 in here.
Okay, and we don't care about.
Yeah, I don't care about that 6 on the outside.
Yeah, okay, got it. Sorry, got it.
No, you're good, you're good. Okay, then I put a number between negative 7 and 7. Any number. What's the easiest one? 0. So if I plug in a 0, I get a positive. Give me a number between bigger than 7. 8, 9, 10. 8, 9, 10. Negative. Sorry. 7, 8, 9. That's what I meant to say. Cool or not cool? So where am I? No. Yeah, that's enough yawns for you, miss. So where am I increasing?
Between negative 7 and 7.
Perfect. You're going to say f is increasing for negative 7 comma to 7. You can put it in brackets or you can put it in parentheses. Yeah, because it starts increasing at negative 7 and then it stops increasing at 7. 4.
Sorry.
If you were writing this on the AP exam, you would, or any exam really, since f prime is positive on negative 7 of 7. That would be full credit. F is increasing for negative 7 of 7 since f prime is positive on negative 7 of 7. No, well, eventually yes, but for now, no. Right now we're just getting, right now we're just getting better at just knowing where you're increasing and decreasing. How do we feel, guys?
It gives proofs energy where I have to just like say something that I think is given.
Oh my god.
Look, no, we're almost done. Last question. And then you have just a really fast assignment. No, don't worry. It's going to be fun. You're going to have fun on this one. Use the graph of the function f below to estimate f prime is 0, positive, or negative. All right, this one's a simple one. Where is f prime 0 on this graph?
1 and negative 1.
Perfect. At negative 1, everyone do this and put a little horizontal tangent line. And go to 1 and put a little horizontal tangent line. And you can write there, you can write f prime equals 0, f prime equals 0. Does everyone see how f prime equals 0 there? If you have colored pencils, this is a good place to put colored pencils. I'm going to use green. Tell me where f prime is positive.
Negative, or between, negative.
You can say negative infinity.
Negative infinity to negative 1.
So between negative infinity to negative 1, and there's another one where?
Between 1 and infinity.
1 and infinity. So let me go ahead and write it here on the side what I'm doing right so far. So I know f prime of negative 1 equals 0, and f prime of 1 equals 0. And then I know f prime is positive on intervals. Notice that I'm writing intervals. So I'm going to write negative infinity, comma, to negative 1. So since I wrote f prime is positive, that's all I care about. And 1 comma to infinity. All right, I'm going to slow down because I want to make sure that we know. Do we know the difference between saying f prime is positive and f prime is increasing? And it's okay if we don't. If you would have written the same thing for increasing, I would have counted it right. But if you were to say on where am I increasing, you would use brackets on that. Since Chubb, why didn't you use brackets on this? Because on this one, I just want to know where f prime is what? Positive. And you're not positive at -1. Right at -1, it's 0. And you're not positive at 1 either. Right at 1, it's 0. Does that make sense? So that's why you got to use parentheses for those. But if I told you where is f increasing, then you would say f is increasing from -infinity to -1 bracket, because the definition of what increasing means, and from 1 bracket to infinity, parenthesis. Does that make sense? Okay. And one more color. I'm going to use black, the color of my soul. It's not. I do appreciate Christmas. I just wouldn't put a Christmas tree before Thanksgiving. My neighbor put the Christmas lights on like 2 days before Thanksgiving, and I was gonna tell her, like, you know what? Don't talk to me. Nah, she's cool. She's a cool lady. I would not. I like her.
Is that the neighbor that brought you food?
Yeah, she brought me a lot of food. She just brought me food, like she brought me food on Tuesday, then she brought me food Wednesday, and then she brought me a lot of food Thursday. Like, I don't know if she was just like, man, this guy doesn't cook, let me just bring him food. So she just kept bringing me food. Hey, what happened, guys? Wow, was it? All right, here we go. Here we go. F prime. All right, guys. F prime is negative from what to what? -1 to 1. So I'm right. F prime is negative on the interval -1 to 1. And there it is, nice and color coded. The reds mean 0, the greens mean positive, the black means negative. How do we feel, guys? All right. We have a very simple delta. Relax. Like, you're actually not even calculating anything. All you're doing is identifying what's max, what's min, and identifying where you have a positive slope, where you have a negative slope. That's all you're doing. Let me know if you have any questions. Ms. Gonzalez, I hope you enjoyed today's notes. And everyone in the class says hello to you. Oh, no, yeah, they do. All right, talk to you later, miss.